Hi there, and thanks for joining us as we discuss the last process of pharmacokinetics, which is the excretion of medications. For our purposes right now, the most important thing to know about excretion has to do with the half-life. And the half-life of a drug is the time that it takes to reduce the concentration of the medication to half the original amount. So if you had 8 milligrams of medication in your system at 12 o'clock and that drug had a half-life of 1 hour, that would mean that there would be about 4 milligrams of drug in your system at 1 o'clock. But for most drugs, it doesn't continue going down at that linear pace. It's not eliminated at a linear rate. Most drugs are eliminated by first order kinetics, meaning that your calculations basically start over at 1 o'clock, estimating half of the remaining amount. So at 2 o'clock, you would have 2 milligrams of the drug remaining in your system. And normally, there's about 5% of the drug that remains in the system after about 4.5 half-lives. And at this time, you may be wondering, well, what's the half-life of alcohol? And it's a good thing that you asked. The half-life of a drug is relevant to drugs that are metabolized by first-order kinetics. Most drugs are metabolized by first-order kinetics, but alcohol is metabolized by zero-order kinetics. And that means that we metabolize a given amount per period of time rather than the varying amount that is seen with drugs metabolized by first-order kinetics. This happens when a drug is being taken in such a large dose that it overwhelms the capacity of the enzymes that degrade it. So for alcohol with zero-order kinetics, we estimate that approximately 1 standard drink is metabolized per hour rather than saying that it has a half-life of X hours like we say with most drugs. Another interesting thing about the alcohol is that it induces enzymes that are necessary to metabolize the alcohol. In other words, it increases the number of enzymes that are metabolizing the alcohol, and therefore, if you've become intoxicated for the first time in a long time, make sure that you're extra careful before getting behind the steering wheel, because your blood levels of alcohol will stay up a lot longer than average. Well, that's all for the final process of pharmacokinetics, the excretion of drugs. Make sure that you take the quiz on this section and that you reinforce your knowledge of this information with that quiz. Thanks for joining us. I have a question for you about the half-life of medications. If there is 4 milligrams of medication in the system at 12 o'clock noon, and the medication has a half-life of 4 hours, when would there be an equivalent of 1 milligram of medication left in the system? And you were correct if your answer was at 8 o'clock p.m. If 4 milligrams of medication was in the system at noon, the medication would have metabolized to the point that there was 2 milligrams left in the system at 4 o'clock. But remember that it doesn't continue to go down at a linear rate. We need to basically start the timer again. We can't just continue at that rate of metabolism. So it's like having 2 milligrams of the medication in the system at 4 o'clock, and 4 hours later, of course, there would be 1 milligram left. So that ends the summary of pharmacokinetics, which includes the absorption, distribution, metabolism, and excretion of medications. At this point, you don't need to know everything about pharmacokinetics. We've just overviewed some very complex concepts of pharmacology, and you will still have questions. But if you were able to understand this overview of pharmacokinetics, you have a really good foundation to move on and understand the pharmacokinetics of other medications where you'll add to your knowledge.